Welcome to part 2 of section 2.2. So good morning, students. Good afternoon, students. So what we're going to do is we're going to add a little bit to what we learned last week. And if you go and open up your packet that you had last week, last class, and open it up to example 3. If you need to, go ahead and pause this video until you do that, and get back to it. A couple things I just wanted to say. I didn't mention them before, but if the video ever goes really slow with YouTube, remember that you can change the settings for the playback. So if you're able to listen to it faster, you can go ahead and set it for a faster speed, that'll allow you to move through it a little quicker if things seem to make a lot of sense. What's going to happen now is we're going to do this next part, and again, one of the things that we're doing here is trying to examine all aspects of a parabola, and that's why. So that's basically what we're doing is dealing with all the different characteristics, all the different ways we can express a parabola. But this one here, this next little section is about we call minimum and maximum values. And if you remember from last time, a minimum occurs when we have a value that is on the bottom of the parabola. So this is, and then a maximum occurs when we have a parabola that's upside down, if you will, and the vertex is on the top. We call it a maximum. So how do we know whether it's a minimum or maximum? Well, actually, we can tell right off from the equation itself. If we have an equation, look, for instance, I was going to say, if you look on the next page, and again, this is, so how do we find the minimum or the maximum? Actually, it's not that hard, because if you remember the formula that we've been using, x equals negative b over 2a, well, that is the line of the axis of symmetry of the parabola, but it also marks the x value of the parabola. So the x value is given by negative b over 2a. Then we plug in the x value to get the y value. The y value of the vertex is what we call the maximum or the minimum. In this case, the y value is going to be the minimum, because it's an open up parabola. Over here, the y value is going to be a maximum. Ooh, sorry, getting my stuff messed up here. But anyway, and also, once we know what that y value is, it also tells us what the range is for the equation. So let me show you how that works. So this gives us a little bit more information. So the range is going to be, say for instance, we are able to figure out that this minimum on this parabola here is, I'll say 2, 3, just arbitrarily. So if this is 2, 3, then that means that the axis of symmetry is what? You're right, x equals 2. And the minimum value is the y value, because this is at y equals 3. This is the bottom of the graph. So we'll call the 3 the minimum. And if we know that the minimum is 3, then the graph is everything above it, so we would say that the range of values is going to be y is greater than or equal to 3. So finding the maximum or the minimum allows me to know what the range is. Let's go ahead and play the same hypothetical game over here, and say that this point is again something like 2, 3. So that tells us two things. It tells us the axis of symmetry is 2. It tells us that the maximum is 3. That means that the graph is occupying the y-axis anywhere from 3 to below. So the range would be all values of y less than or equal to 3. You see how that works? So by finding the minimum or the maximum, we also can very quickly write what the range is. Also, when we know the x value of the coordinate, that's what gives us the axis of symmetry. So there's all sorts of information that we get pretty quickly just from starting with the x equals negative b over 2a. So again, we use x equals negative b over 2a to find the x value of the vertex. It also tells us what the axis of symmetry is, and it also is the value we plug into the function to find the maximum or the minimum. So it all starts here. So let's go ahead and apply. I didn't take any notes on that. That was just my introduction to what we're going to be doing in a moment, and hopefully we can hopefully we can move on from here. Let's go take a look. Let me erase this though right now, and we'll move to the first problem, to the first example. Okay, so it says find the minimum or maximum value, for example 3, find the minimum or the maximum value of this function here. F of x equals 1/2 x squared minus 2x minus 1. So again, we're going to go right to our starting point is going to be that the value h, the x value of the vertex, is going to be negative b over 2a, which equals, okay, b is negative 2, so negative b is going to be 2 over 2 times a, which is 1/2. 2 times 1/2 is just going to be 1. Therefore, our value for h is 2. So think again. Now, what do I do now that I know the x value of the function? How do I find the y value? Well, if you remember, the next step is always to plug in our x value, 2, into the function. So it's 1/2 2 squared minus 2 times 2 minus 1. 2 squared is 4, and then the 1/2 of that 4 is going to be 2 minus 4 minus 1. We're almost there. F of 2 equals, that's going to be 2 minus 5, or negative 3. So there it is. 2, negative 3 is our vertex, which means the axis of symmetry is x equals 2. And what is this, though? This negative 3, is that a maximum or a minimum? Take a moment, think about it. Is this a flip parabola or a regular parabola? And it is a regular one because the coefficient in front of the quadratic is positive. If it's positive, it's a u, not an upside down u. Therefore, it's going to be a minimum. And knowing that that's the bottom, the minimum of the parabola, it also tells me that the range will be all values of y greater than or equal to the negative 3. So that's all that, look at all that information that we get from there. And so let's view one more aspect of the function that we that was in our diagram that you might have been wondering about. Is this you guys see these words increasing and decreasing? Well, what happens is these also become terms that are useful later in mathematics, but it's a great place for us to introduce them. Decreasing function, we look at functions from left to right when we try to figure out whether they're increasing or decreasing. So if you look at this function, the first function here, you'll notice if you're going from left to right that it goes downward until we get to the minimum, and then it increases as we leave the minimum. And again, the idea is to move from going from left to right. let's go to the next graph here. We're going to go increase all the way to our maximum point, and then we decrease all the way after that. So again, these are terms that will be very helpful for us in the future, and so we're trying to learn them now. So let's think about this function that we just did the work on. So we have, basically, we have a parabola that has a vertex at 2, -3, something like this, and we know that it goes up because of the positive coefficient in front of the x-squared term. So now we have the ability to say where the function is increasing or decreasing. So remember that here is the axis of symmetry at x equals 2, and we know that if we go from left to right, that it's going to be the function decreases to the left of 2. So decrease to the left of 2, and then it also increases to the right of x equals 2. I probably should have wrote x equals 2 over here too, but anyway, x equals 2. Got it. So anyway, in summary, we have a few things going on here. We're just basically we've done all these things, but we just didn't interpret them the same way. So now that we found the vertex, we can also look at the y value as being either a maximum or a minimum. We will also know if we know what the y value is, and whether it is a turned up parabola or an upside down parabola. We can also get the range from that equation. Add to that the increasing and decreasing concept, and that's it for example 3. Now, let's go ahead and you have an opportunity to practice this on the next page. We have in a moment we're going to be finding the minimum and maximum, but remember that the value a, which is the number before the x, if it is negative, it's flipped. If it's positive, it's not. So if it's a positive value, we'll always have a minimum. If it's a negative value, it's an upside down parabola, then we have a maximum. So negative values for in front of the stretch or shrink are what determine whether it's going to be a maximum or a minimum. So let's go ahead and go back to, give me 1 second to erase these values here. Let's go back to the other page. And so what I'm going to ask you to do here is take a moment, and maybe I'll start you off with A. First of all, let's go ahead and do this together. This one first. Actually, let me do B first. Let me show you why. The reason I want to do B first is because on B we have this. We have a -1 for A, so A equals -1. This B equals 5, and C equals 9. So what's important about the fact that A is -1? Well, that's a -1 stretch, right? Well, it doesn't really stretch one, but if the negative means a flip. So that means that we have a parabola that's an upside down parabola, which means that our vertex will become a max. Got it? Okay, so let's go ahead and see if we can figure out what that maximum y value is. So first thing we need is the x value of the vertex. So we're going to take our h, x value of the vertex, equals -b over 2a. Have we seen this enough yet? -b is -5 over 2 times -1, which is just going to be a +2. And so the value for of h is going to be -2.5. I'm just going to call, actually let's just call it -5/2. So I'm sure you're already loving the fact that that's a fraction, but let's live with it. So let's go ahead and see what happens when we plug that value into the equation to get the y value. So now we're going to go h of negative 5 halves equals negative 5 halves squared plus 5 times negative 5 halves. Plus 9. So that looks like a lot of excitement here. Let me, this becomes negative 25 halves, 25 fourths, plus, I should say minus 5 times negative 5 is negative 25 halves plus 9. I would go ahead and entreat you right now to put this in a calculator. If you do put this thing in a calculator, you're going to get 15.25. So now comes the question, would you give me something like that in a test? The answer is, not without a calculator, I wouldn't. So anyway, h of negative 5 halves is equal to 15.25. And so the final, so the vertex is negative. I'm just going to go write negative 2.5, which is the same as 5 halves, and 15.25. So now, what information can we get from this vertex? Well, first of all, we know that the axis of symmetry is x equals negative 2.5. We also know that this is a upside down parabola. So this value of 15.25 is the maximum value. So it has a maximum value at 15.25. And we also know that it's going to increase. It's going to increase to negative 2.5, and it's going to decrease beyond to the right of negative 2.5. And I should say increase to the left. So anyway, a lot of information we're getting from that. The A is a little bit kinder. So if you would be daring enough to go ahead and try to find the axis of symmetry, the minimum or maximum, and the areas of increase or decrease, and also the range. Oops, we didn't do the range. The range is going to be y values that are less than, why less than? Because it's a upside down. Less than or equal to. So anyway, a lot of information there. Most of the information we've been pulling out of it anyway. We're just changing with the meat. We're just assigning different names to those values. For instance, the y value of the vertex now represents the maximum or minimum. It also helps us understand the range. So we've been getting these values before, but we just didn't recognize that they also helped us with the range and other things. So what I'd like you guys to do right now is to do problem A. Be brave, and I want you to find the minimum or maximum. I want you to find the range, and I want you to figure out where it's increasing and decreasing. And it all starts in standard form with negative b over 2a. So I'm going to pause right now. I want to ask you guys to try to pause right now and pause this video and see if you can't determine those numbers. A is a little bit nicer, no fractions on this one. Okay, let's see how you did. Again, we don't have to graph to do this. So looking at A, if you go to the top, let me go change the color of my pen. Looking at the top, you see that A is 4, B is 16, C is negative 3. So I'm going to go here to determine my value for H, plugging in positive 16, negative B 2 times 4, or 2 times 4. So I get an h value of negative 2. I plug in the h value of negative 2 to get the y value, which becomes negative 19. So that becomes my minimum. Why is it a minimum? Because a is a positive 4. It means it opens up like a regular parabola, and so the vertex is on the bottom, making it a minimum, which means the range is going to be greater than or equal to negative 19. Greater than because the whole parabola is above it. So greater than when we have a minimum, and it's going to be less than when it's a maximum. So this means also that to the left of the vertex, remember that the axis of symmetry is x equals negative 2. To the left, it's going to be coming down, and to the right, it's going to be going up. That's what decrease and increase is all about. So that's it. If you were lucky enough to pull that off, you're in very good shape for understanding maximum and minimum, increasing and decreasing. So again, we didn't do anything brand new here. It's just that we're reinterpreting the values that we've been using before. Last page, all right? Turn to the left. 18.25 page. Well, actually, it's not necessarily the last, but it's we're getting there. There is yet one more way that we can express a function, and that's going to be called intercept form. Intercept form is the form of a function that looks like it's factored. For us to let me give you an example, and you notice we're going to talk about Desmos in a minute. We're going to use Desmos, but here's an example of a quadratic. If I have a number, a function y equals 2 times x minus 3 times x plus 4. So what I want to do is I'm just going to take that equation and I'm going to put it in Desmos. So let me open up a browser and see if I can get this in here, so you can see it. And then I think once you can see it, once you see the pattern it produces, it's pretty cool. So I'm going to put it in y equals and 2 parentheses x minus 3, and then another set of parentheses. Oops, I don't think it's going to want me to do that. Let me move over x plus 4. Now you do not need to do this, just watch me. Stay patient. All right, well, you'll notice that that it did draw a parabola, and it's a very steep parabola, unfortunately. But what I really want you to look at is this part of it. I want you to look at the x-axis, and I want you to notice where it crosses the x-axis. See if I can make this a little bigger so that the numbers show up. It'd be cool, but maybe not. Okay, well, let me show you. It's crossing the x-axis at 4. Sorry about that, negative 4. And also at 3. So I want you to look up here at the original equation, and you'll notice that there's a x minus 3 here and an x plus 4 here. So that means that if it's in this form called the x-intercept form, that it touches the parabola, has points on the x-axis of 3, kind of opposite world here, and negative 4. So do you see that? I hope so, because basically the intercept form, when a quadratic is in this form, all I have to do is take the opposite of the values inside the x, and that gives me the x-intercepts. So let me move this. Let me see if I can move this off to the side. All right. over there. Okay, good. So so another example, so this one says that I have x-intercepts that go at 3 and -4 on the x-axis. What would it mean? Test your metal here. If y equals 3 times x plus 5 times x minus 7, where will this one cross the x-axis? Well, it's going to cross the axis twice again, and it's going to be at x equals -5 and at x equals 7. Basically, we're looking for the values of x that create 0 inside those parentheses. So the -5 and the 7 are where it's going to cross the x-axis. So using those two values, we should be able to get a lot of information on how to graph the parabola. So let's take a look at this first example. So let me square things up a little bit here. Okay. So here, where is, from what we were just talking about, where is this f of x here going to cross the x-axis? It's going to cross the x-axis. What value for x produces a 0 in here is -3, and the value here is going to be 1. So at x equals -3 and at x equals 1, we should have 2 points of the parabola. So let's go ahead and put those in. So 1, 2, 3, and 1. Why does this do this stuff? Oh, anyway, and 1. So we know that it's a parabola that, because it's a -2, we know that the parabola is an upside-down parabola. So that means we know it goes like this. So we're looking for a maximum. We're going to be looking for a maximum on this case. Question is, how do I figure out what the vertex is? Well, if we know that the parabola is symmetric, then we know that the axis of symmetry will go right between those 2 points. And the axis of symmetry is x equals -1. So that means that we know that the x value of the vertex is also -1, right? How would I get the y value of the vertex? Were you ready to were you able to figure that out? It's going to be when I plug in the x value of the vertex into the equation. So I got -2 times -1 plus 3 times -1 minus 1. This is -2 times 2 times -2. And so what are we up to? 2 times 2 times 2 is 8, with 2 negative signs, making it a positive 8. So that means at f at -1, 8, we have a vertex. So -1, 8. Somewhere up here, I hope. So at -1, 8, we have the vertex, so we know that the parabola goes down this way, and we know the parabola goes down this way. Yay, pretty cool, huh? So again, when we're in x-intercept form, what we can do is find the 2 points on the x-axis. Once we know that, we can easily find the axis of symmetry, which gives us the x value of the vertex. Then we plug in that x value, and we get the vertex at -1, 8. A couple other things we can know now is that we have, is 8 a minimum or a maximum? Well, it's at the top, so it's a max. And we also know it's increasing to the left of -1, and increasing to the left of -1 and decreasing to the right of -1. So I think that we have all the information. Let's label the x-intercepts, which we did, and the vertex, and the axis of symmetry. And again, one more thing just to remind you is that if we're in this form, that we're looking for the x values to produce 0. Why is that? Well, the x-axis happens, the x-intercepts happen when y is equal to 0. And those are values that that make f of x equal to 0. If I put a 3 in for this -3 in for that x, the whole equation goes to 0. and where y equals 0 is at the x-axis. So the two values that get produced zeros for y are going to be the 3 and the 1 and the -3. I don't know if that made any sense to you, but if the easiest thing to do is just say opposite world there, you're fine too. So now what you have, couple quick ones to graph. I will let me help you with number 7, and then you can try number 6 on your own. Okay, so x-intercepts, people, let's take a look. Right, which values for x produce our zeros in the parentheses? Well, I'm going to say 6, and I'm going to say 2. So I'm going to say 6 is definitely a 6, right? 1, 2, 3, 4, 5. Let me get this big. So here's one x-intercept, and the other one is here. Now we should be able to find the axis of symmetry to get the x value of our vertex. The axis of symmetry looks to be at 4, right? So now I know the x value of the vertex is 4. I go g of 4. Always my second step, right, is once I've got that vertex. What's nice, we didn't have to use negative b over 2a, but it's going to be 1/4 times 4 minus 6 and then 4 minus 2. So 1/4 of -2 times +2. Ooh, sorry about, can't keep my hands out. There's little buttons on the bottom of this thing that every time I touch, they moves this, but I apologize. So anyway, so that's going to be 1/4. Think about this. What is 1/4 of -4? That's going to be -1. So here's our parabola. Our parabola vertex is going to be 4, -1. So it's down here. So it's a big, fat, wide parabola. And why is that? Because you can see it's been shrunk, right, by 1/4. And see the shrink over here, 1/4. So let's go ahead. We know it's increasing, but it's decreasing to the left of 4 and increasing to the right of 4. We also can see that the value -1 is a minimum, and therefore the range is y is going to be greater than, it's going to be bigger than -1 or equal to. All right, well, once we do number 6, we'll be done, and you'll be off to your homework assignment. But let's, why don't you pause for a moment, take a deep breath, and see if you can't conquer 6. Now again, in this case, what's going on is we're not using the -b over 2a to find the x value of the vertex. What we're doing is finding the two x-intercepts, and from there deducing the axis of symmetry, which allows us to get the value of x, which we plug in. Again, the plugging in part is similar to things we've done in the past. Take a pause and see. I'll pause this and come back in a moment and take a look and see how you did. Okay, let's see how you did. The x-intercepts from the original equation should be -1 and -5. And we get those again from here and here, the values of x that create 0 on the right side of the equation. And once we graph those points, the axis of symmetry looks to be x equals -3. So we're going to take that -3, which is also the x value of x coordinate of the vertex, plug it in. And if we do our math right, we end up with f of -3 equals 4. Therefore, -3, 4 is the vertex. From there, we can see that it's a max. And if it's a max, then the graph is going down, less than. So it's so we write the range as y is less than or equal to 4. Now, Because this is a shorter class, I'm gonna hold off on going into the next part with the problems. I'm gonna see if we can't just stick with this work for now. But one of the cool things that we do have for quadratics is the ability to mimic actual projectiles, things that are being shot through the air, and and here's some examples of some real life problems that we can we now have the tools to apply to. But I think that what I've done so far is enough for the day, and what I'm going to ask you to do right now is go to homework assignment. It's going to be be called A2 HW 2.2B. It's going to be our second assignment in this section. So good luck with that, and then we'll have hopefully a nice day tomorrow, and I'll see you soon. Take care.